I'm hurrying is approaching a stoplight moving with a velocity of plus 30 meters per second. When the light turns yellow, IMA applies the brakes and skids to a stop. If IMA's acceleration rate, the rate at which she slows down, is negative 8.00 meters per second square, then determine the displacement distance of the car during the skidding process. So if we put a couple cars up here and take a look at it, we know that the car in the beginning is traveling plus 30 meters per second. And the car at the end is traveling 0 meters per second because IMA stopped for a stoplight. Alright, but the question becomes, this is a velocity. Which velocity is it? It's the velocity initial. And so that makes this the velocity final. So our givens, velocity initial, equals plus 30.0 meters per second. Our velocity final equals 0 meters per second. The final thing that the question gives us is acceleration. And they actually say that acceleration equals negative 8.00 meters per second squared. What they want to know, though, is the displacement. And that's going to be in meters. So I'm going to use the equation velocity final squared minus velocity initial squared equals 2 AD. When I replace numbers for letters, velocity initial is 0, but I'm going to square that, minus the quantity 30.0 squared equals 2 times the acceleration is negative 8.00 times d. When I do the math, I get 0 minus 900 equals negative 16d. In order to get d all by itself, I'm going to divide by negative 16 on the right so that I cancel. But whatever I do to the right, I got to do the left as well. And I find that when I do the math, d equals 56.25 meters, which is fine. That's a calculator answer, but if I want to significant figure it, I see that this number has 3 sig figs and this number has 3 sig figs. So my answer is going to have 3 sig figs. And so I can go 56.3, or depending on your rounding rules, 56.2, and be sure to include the unit, meters.